Emma, the audience is yours.
Thank you. Sorry, I understand I stand between lunch and yourselves, so...
No, take your time, you have it.
Yeah, so the background about myself, yeah, I'm from Atkins Realis, so it's an engineering consultancy, if you've not come across it, and I'm an engineering geologist by trade, but I've also got a background in data science because I did a master's, so any excuse for an overlap, which I'm all for. So yeah, my talk's about machine learning applications for geohazard identification. It's a more high-level overview to kind of targeted more towards people in industry who might not necessarily have done any machine learning applications through university or academia and are really interested in the last 10 years of technological revolution. So again, I want to discuss the my aims of the project, my aims of the talk, the background and the understanding of the problem, as well as how we can integrate geological expertise in the machine learning workflow, and go over a bit of a short case study that I did, as well as some challenges and future direction. And I've just peppered in some photos, otherwise it'd be very wordy. So coastal erosion at Holderness is another. So like I've said, it's a high-level overview of a typical workflow for machine learning projects. I want to show how accessible these techniques are to engineering geologists, geomorphologists, etc., who might not have necessarily been exposed to this at university and they're in industry and really want to do something to do with AI or machine learning and can be quite inaccessible or seem a bit overwhelming, or not for them, it's not the case. And I hope at the end of this, I want to reiterate how important your outcome is based off the fundamental geological knowledge and understanding. Yeah, and another geohazard, so a sinkhole in South Wales. Remember this? So yeah, if you're not familiar with geohazards are natural geological processes that impact adversely on people and the built environment, and examples of landslides, sinkholes, soil, etc. And this becomes obviously more important with geohazards with climate change, as that is going to be a hot topic and a lot more geohazards. So this is a famous landslide in Derbyshire, so at Mamtor, where the landslide took out the road and they had to divert the road elsewhere. So with a geohazard assessment methodology, traditionally, what would you be doing? So you'd be doing desk-based assessment using GIS, remote sensing, satellite imagery, as well as field mapping, I should imagine, and data collection in person and site-specific data. So why would you use machine learning if you're doing all this kind of thing anyway? Well, you pretty much have the data at hand, so why not do something with it? And the way geohazard lends itself so nicely to machine learning is because it's got lots of features, as you can imagine, and lots of different variables that go into it. So exactly, you're already you've got it there, you're probably using GIS, you've got attribution at your fingertips, so you employ the next steps. So first, we really want to understand the problem of why you would do machine learning. So are you trying to classify existing occurrences for management? Do you want to narrow down your areas to target? For example, if you've got a large area and you want to do ground investigation or reconnaissance for a site visit to go and see some features. Are you trying to predict the occurrence of events? Perhaps your client, you've got things going on in your embankments and you want to kind of really funnel down where you could get these kind of events. Do you want to do kind of a large mapping exercise like susceptibility of a site to geohazard, potentially do red, amber, green type things, or a heat map? Or you're trying to achieve something new, as we've seen like this morning, lots of exciting things. So as well as understanding the problem, you really need to understand your data. So you need to identify the data type. So in terms of geohazards, we've seen a lot of like numerical data today, and geohazards, a lot of them tend to be categorical. We've got some numerical data, but what's the geohazard type? So is it like a landslide feature, landslide event, point data, Is it something like shrinks well, plasticity, something like that? So data size, how much do you have? For machine learning algorithms, need a lot of data, and some algorithms perform better with large data sets like neural networks, whereas some of them can be used for smaller data sets like decision trees. So the rule of thumb tends to be 10 times the amount of features than variables. So data quality, the next one, assess the quality of the data. So include the presence of noise, missing values, anything like that. I just literally just said, robust algorithms like random forest can handle noise better. In terms of like that old adage, rubbish in, rubbish out. Not really know what you're doing. So the first steps, as a geologist, what is your role in terms of your geological expertise? So you'd be identifying the most appropriate data sources, your geological mapping data, test data, historical records, satellite imagery, and using your knowledge to go through and understand what's the most sort of like high-level overview of important variables. And that would be ensuring accuracy as well as comprehensive. Some of the data might be labelled as well. Part of this would also be linking into getting, you've got unlabelled data, you might want to think about how you're going to label it as well. And it's not just using absolutely everything in order to simplify the model. You could kind of go more to a narrow field. So next step, preprocessing, so your data interrogation. So key geological input here is like the data cleaning and the feature selection. So any outliers or inconsistencies with the data. So for example, if you'd look at landslides, for example, you might see from literature or general desk study information that slope angle, superficial and bedrock geology, as well as groundwater and weather data are the most important. So they're your critical variables that you want to be getting some really good, clear data for. So model selection and training. Obviously, there isn't a one-size-fits-all to model selection. As you know, everyone's got, from the posters and the talks and stuff, everyone's selected their most suitable models. So the types of models depend on the nature of the geohazard, the task and the data type, as well as how linear or complex the data is. Something that can handle multiple data types, like decision tree based, or also in industry as well. We tend to like interrogatability. So something that can be checked and reviewed by other people who aren't necessarily familiar with machine learning techniques, whereas something like a neural network can be a bit of a black box, and that might not necessarily be appropriate for that type of industry. So the availability of the test and training data set, this is the big one, especially in consultancy where a lot of data is behind a paywall. Is data that you might not necessarily have full access to kind of countrywide databases. It might be more site specific. So you want to kind of consider the ratio between what you can have in terms of using your test and train data and your kind of brand new unseen data. So obviously you don't want to kind of go down the line of having a small test and train data set because you might get some overfitting. Oh, shoot, went the other way, sorry. So model validation, that's part of like, obviously with cross-validation as well as geological validation of the model. So using cross-validation to assess the effectiveness of your model, see how it performs to unseen data. As well to mitigate overfitting where the model fits, the data fits the model well, but isn't as good as unseen data. So obviously using geological real-world validation as well helps to see if they make sense from a geological perspective, especially with your QC, and test model robustness with your, model evaluation metrics to look at. So classification, you'd be looking at like something like accuracy and precision, whereas if you've got regression, you might look at like R-squared. So again, this is the very end would be providing your insights and reasoning based of the knowledge that I think everyone here who's got a case study of a project, their geological knowledge is imperative to understanding why the model is doing what they're doing and how you're going to use these for decision making and planning. Do you have a client that you are referring back to? Is it communication at risk? Is it something on a large scale or something on a small scale? So, yeah. So yeah, a short case study. So this was part of my MSc project. I did a comparison of machine learning algorithms to predict sinkhole occurrences in interstratal karst region of South Wales. So looking at specifically collapse dolines. So used a DTM 1 metre resolution LiDAR data and some Python code to create a case study area data set of 180,000 depressions. So the LiDAR picture with the different colour delineations on is me kind of deciding how big of the data set to create, whether it's green and it's really tiny, or to just include the bigger ones, which is like the purple colour. And variables used, so depth, shape and size, bedrock geology, superficial thickness, of the cover geology as well, because it's a collapsed doline, there's a cover thickness, as well as cave entries and distance of watercourse and longinus. So the 4 machine learning algorithms I applied: logistic regression, naive Bayes, random forest, support vector machines. So the worst performing ones were logistic regression and naive Bayes, which had poor model performance, whereas random forest and support vector machine performed better and had the most accuracy in predicting sinkhole occurrences. So in terms of random forest and support vector machine, they were both very good, but the accuracy and prediction were better for random forest marginally. So the ROC curve there is for the random forest. So yeah, I also use 5-fold cross-validation. And the random forest model is, because it's a decision-based tree, it can be visualized and interpreted as well as looking at feature importance. So that was ultimately the most interpretable model with regards to feature use. And also as an MSc project, you need to be able to discuss results. So challenges and future directions. So again, data quality and availability. It's where you're going to get your initial variables, your test and train data sets. Big data, there's so much data, and yet sometimes it's not that accessible. That's a big issue that we come across, especially in industry, is if it's behind a paywall, what is the state of it, who collected it, and can you trust it, who takes on that risk as well if you're going to use other people's data. Model interpretability, so the knowledge between geologists and data science, there's that crossover, and obviously the people in the room here said otherwise, but there is limited crossover sometimes between the two different sciences, so it's trying to have the explainability of these models and trying to really hammer home. So time as well, computer power and processing time. In industry versus, academia, you've got a little bit more time in order to run models, but we might be under quite strict deadlines, program restrictions, so some of these data sets, like the 108,000 one, that took a lot of computer power, of RAM that I didn't have to run, as well as the perception availability. Now I'll put this on here, and obviously we're at an AI conference, so this isn't true, but I would find that sometimes it's really difficult to try and move people's mindsets into machine learning is not for us, but it is. You're kind of already doing it. You've got, if you're using GIS and attribution, you're labeling your data already. It's just a few lines of code. You're kind of already in, you're looking at spatial data in GIS, just adding that extra little bit, you can really get some really interesting things going on. So the future I see between data providers, producers and consumers, as well as industry and academia. Industry, we've got access to client databases, things like that. Academia, knowledge of all this fantastic work and the best knowledge of what's been done. And also data science and geologists to try and explain the terminology between the two. I think we've all got to speak the kind of same language. And yeah, just a summary and discussion. So geohazards make great machine learning applications because of data. Machine learning is accessible for everyone. Geological knowledge and engineering judgment is not being replaced. And successful outcomes are based on geological knowledge and robust understanding of what is going into that model. That's it.
Yeah, thank you very much, Emma, for this very interesting talk on a really relevant application of machine learning. I'm sure there are some questions around. There is one, please.
you have any tips for communicating what can be quite scary geo-uncertainties to quite risk-averse engineering clients?
Wish I knew the answer to that. I think just generally in terms of communication and risk, I think lots of maps or applying uncertainty, maybe like heat maps and things like that, if it's point data. It's, especially in industry, it's who takes on that risk, and I think it's just communication of it, and I think anything visual, is great. So I think mapping, if it's maybe susceptibility or something like that, I think that's a really good option.
1, 2. Thank you.
Tariqul Islam.
Yes, please, Tariq.
Which type of geospatial tool did you use to implement machine learning in your case?
So I flip-flopped between just GIS, using QGIS, and just some Python code. So the actual code itself is like a few lines of Python code in a Jupyter notebook, but most of the pre-processing and attribution is just in data. So it's whatever, whether it's Python or QGIS handled the data best, but it was, because it's all geospatial, QGIS is kind of the one.
Mm-hmm. Okay. Yes, please.
I enjoyed your case study of the sinkholes at kind of a regional scale, but in industry, which is where I am too, we often have projects kind of at the site scale. And I wondered whether you actually managed to translate what you'd learned in your MSc into real projects at Atkins Reaglis.
Specifically for sinkholes, not at the moment, but I was inspired by a project that we did for a pipeline where we were looking at large swathes of data, and that's something that inspired me, but I haven't been able to implement it directly onto site. I think it's the amount of data that you'd need, so that's why looking at something kind of more regional context is good. I think there's like ethical, there could be, I suppose when you're looking at, I chose a rural case study as well, because sinkholes, especially if you're looking at more urban areas like Ripon or somewhere like that, it might be getting into the ethical the aspects of it. So I'm looking forward to doing something, but yeah, we just need that big data set. So someone like Network Rail, who've got lots of embankments, or like HS2 or something like that. That's what we're kind of hoping for.
Sounds good to me. Do we have any more questions? Yes, please. Yes, please. And then there will be Charlie, and then there will be a photo, and then there will be lunch. So.
Can you hear me okay? Perfect. So with some of these geohazards, often they can be quite rare events, and they often what you're really interested in are tails, so right into the edges. Have you got any thoughts about how you deal with those kind of situations? Obviously, if you assume everything's Gaussian, you might not be looking into these kind of extreme events on the edges, which is really what you're worried about. So, have you thought about that at all?
Is that kind of like the large scale events that like, or just in general?
The Boxing Day tsunami, right, which doesn't happen very often, but is the thing that we should be really worried about. The occasional landslide in the sea where you don't even see a bubble on the ocean floor, you're not really worried about. So with the geohazards, it's the really extreme events that we might be worried about most, but you might not have any data for it, or very few data for it.
Yeah, exactly. I think as well, if you're, depending on what kind of input I've seen when I was doing the literature review for it, there's some good case studies about like including temporal data, as well as climate, weather data as well. Yeah, but I suppose it's the very small ones. I think generally just in my day-to-day role, we'd be looking at the small kind of insignificant things, but significant to a site, but wouldn't necessarily be like an event of that size. But I think, yeah, any thoughts on anyone else? I'd be interested to hear how.
I think it's nice that the kind of example you're showing there is, you can see how that could work there, but you think about something like, I don't know, big tsunamis or something like that. It's so infrequent it can be difficult unless you think about perhaps bringing in modelling or something like that, simulation, so you actually enhance your data set with simulation models rather than just purely from the data, because you just don't have enough data to use. But, yeah, thank you.
Last question.
Yeah, I've never done any machine learning for geohazards, but it's a very public-facing discipline. So do you think there's a higher degree of need for very specific models that like you're really sure about the number of true positives to false negatives kind of thing compared to other disciplines.
Yeah, so like the accuracy and like precision. I think so. I found it difficult when I was doing it to look for like UK case studies, because I think there's more some of the geohazards we're looking at, landslides and things. In the UK, it's either kind of already been done. There's some good research by the BGS where they've got a landslide database, and they did like random forest and that come out some good outcomes. With regards to sinkholes as well, it's access to the databases. So I think people are doing it. I don't know how public it is, and I think people are a bit wary about making it public just because of how kind of important it is. And if the sinkhole opens up in the road, it's on BBC News. So I think I think people are quite cautious.
And thank you so much. Thank you to all the speakers of this morning session, and also to this vivid, which is probably not an English word, never mind, this vivid discussion we just had.